Reinforcement. All kinds of considerations when you look at reinforcement. Wind load, seismic, soil conditions, all these, height of wall, height of backfill against the wall, type of backfill, length of walls, width and openings in the walls. All these items pertain to what the rebar reinforcement will be required. Rebar placement. Different guides to use as per structural engineer design. So if the building has been designed by the engineer, you're going to want to follow their recommendations and make sure that he or she would cover off inspection wise. There's also prescriptive code, which is part of the building code system, and usually it's a building official would look after that, as you would have a building official look at the Amvic ICF guide. If it's been used and been approved prior to build, then that would also be covered off. In many locations, rebar placement needs to be inspected by a building official prior to concrete pour. And I think in most cases it has to be inspected, whether it's by a building official or by the engineer of record. We have an Amvic ICF design guide, Canadian and American version, that we can help people get their lintels straightened out, their wall reinforcement. It's a very good tool to help with construction and with the engineers and or the architects to get things properly reinforced. Lap splices. There's two different types of splices. It's anytime you have rebar overlapping, anytime you have rebar in the wall, it has to be overlapping. So whether it's a contact splice where it actually touches each other, or whether it's a non-contact splice where it runs past, there's a formula. So first of all, it's 40 times the diameter of the rebar for lap splice, and then you can have an offset of up to a maximum of 6 inches based on 1/5 the length of the actual overlap. When it comes to horizontal reinforcement inside these ICF walls, the webs are specifically designed to hold the rebar in place without having to tie with a contact splice joint. On the first course, you're going to want to come below grade. You're going to want to have the rebar holder that's closest to the inside of the wall will carry your horizontal rebar. On the second course, the next notch out will then have a rebar as illustrated in this photo. And then you repeat that pattern back and forth so that when you get to the top of the wall and then you go to place in your vertical rebar, it's held in place by those horizontal bars in the inside third of the wall to make sure it's structurally set up to do what its purpose. There's a quick example looking down through where you can see it go back and forth, and then the vertical rebar would be placed in there and held in place inside that cavity. Vertical reinforcement. It's placed after the wall has been stacked to the desired height. You slide it in place from the top and weave it in between the horizontal bars that we've set in place. For multiple floor buildings, cold joint connections are required as per project specifications. What's going to happen is you'll have to decide how you do that, and it's usually a wet set process whereby you'd pour the concrete and then insert the cold joint connections